This is a short tutorial on revision control and continuous deployment with Git. My name is Simon Deneen. I'm a Director of Java Consult. First, I'll discuss the Git object model, defining some important terms and concepts. Next, I'll cover basic configuration and usage, followed by branching, which allows you to diverge from the main line of development before merging the branches, collaborating with other developers by setting up a remote repository, and enabling continuous deployment to an Azure website. So first, the Git object model. A Git project is a repository comprising snapshots of the history of the project. These snapshots are called commits. Each commit has a tree object representing a directory. This references other tree objects and blobs. A blob stores the contents of a file. Each of these objects has a unique 40-digit identifier calculated by taking the SHA-1 hash of the contents of the object. A corrupted object would generate a different checksum, so this ensures the object's integrity. A commit also has an author, a comment, and a list of 0 or more parent commits. Moving on to the basic usage of Git, I'll run through the main commands. Use the git config command to define the author and email to be used for all commits by the current user. To set up a repository, I'll open a command prompt window in a directory that will contain the project that's being tracked and type git init. This adds a .git folder to the current directory and makes it possible to start recording revisions of the project. Next, I'll add a text file to the working directory, add some text, and save it as Xanadu. The add command adds changes to the working directory to the staging area. The staging area contains new files or modified files that will be included in the next commit. Instead of committing all of the changes made since the last commit, the stage lets you group related changes into highly focused snapshots before committing these snapshots to the project history. Running the commit command, followed by a message describing the commit, the staged files will be written to the local repository. To view the repository's commit history, run the git log command. After modifying the file, I could stage it by running git add again and commit the changes to the local repository. To return the working directory to a previous commit, use the checkout command, followed by the ID of the commit, which can be abbreviated to the first 6 characters. Opening the file, you can see that it's reverted back to its state at the earlier commit. Running git checkout master returns to the most recent commit. Master is the name of a branch which I'll discuss in a later section. We've looked at the basics of using Git at the command line to create a local repository and to track changes. Running through similar steps with Visual Studio, I'll first create a web project. Checking the Add to Source Control box, I'll select the MVC template and OK. In the dialog that opens, I'll select the Git radio button. Opening Windows Explorer, you can see there's a .git folder in the root of the project. This contains the local repository. There's also a file with a git ignore extension. This specifies untracked files and directories, which includes the bin directory. There are a number of graphical user interfaces for Git. I'll use a GUI called SourceTree for this example. Opening the folder containing the repository, you can see that Visual Studio has made an initial commit with a unique ID. Next, selecting uncommitted changes, there's a list of unstaged files. Checking the unstaged files box, these have now been staged for inclusion in the next commit. I'll type a message and click the commit button. Running the application on the Visual Studio development server, you can see the home page. I'll edit the index page in the Views Home folder. Stage, and then commit the changes. Refreshing the page, you can see the modified content. To revert back to the previous commit, I'll select the commit in SourceTree and check it out. This has returned the working directory to its state at that commit, so refreshing the page, you can see the original content. Checking out is safe in that nothing will be deleted from the repository. By contrast, a hard reset will discard any changes to tracked files in the working directory since that commit. The commit history shows that the last commit has been deleted. A branch in Git is simply a pointer to a commit. When adding a new feature or fixing a bug, a new branch can be created to encapsulate the changes. This ensures that unstable code is never committed to the main codebase. The default branch is named master. This branch could be reserved for stable code that will be released. An additional branch, called develop, could be created while adding a new feature. Once this feature has been tested, the develop branch can be merged into the master branch. The steps might be clearer if I use git commands, so I'll open a terminal and create a new branch named develop. Git keeps a pointer to the current branch, called head. By checking out the develop branch, the head pointer moves from master to develop. Next, I'll make some changes to the working directory. In this example, I'll edit the website's register roots method. Running git add dot will stage all new and modified files, and git commit writes the staged files to the local repository. You can see the new commit in source tree. Assuming we're confident that the changes made in the develop branch are stable, we can merge them into the master branch. First, check out master, and then merge the specified branch into the current branch. A fast forward merge can occur when there's a linear path from the current branch tip to the target branch. All Git has to do to integrate the histories is to move the current branch tip forward to the target branch tip. The develop branch is no longer needed, so can be deleted. The merging process doesn't always run as smoothly. If changes were made to the same part of the same file in the two branches that you're merging together, Git won't be able to merge them cleanly. Running through similar steps to the previous example, I'll create a branch named develop, check out the branch, modify a file in the working directory, stage the file, and then commit it. Next, I'll check out the master branch, but before merging, I'll modify the same file that was modified in the develop branch. Stage the file and commit it. You can see a graphical view of the two branches in the user interface. Now, when merging the develop branch into the current branch, there will be a conflict. Opening the conflicting file, Git shows the changes made in the current branch head and in the develop branch. Edit the file to resolve the conflict, and then stage and commit the file as before. Returning to source tree, you can see the merged branches. As before, the develop branch is no longer needed, so can be deleted. Next, I'll look at how Git can be used to enable developers to collaborate on a project by setting up a remote repository and pushing a branch from a local repository. Another developer can create a clone of the remote repository, make some additions or changes to their copy of the project, stage and commit these changes to their local repository, and then push the commit from the local to the remote repository. The other developer could later fetch any new commits from the remote and examine the changes before merging them into their local repository. We can also look at setting up an Azure website and enabling continuous deployment so that updates to the remote repository are automatically deployed to Azure. So, the first step is to set up a remote repository. There are a number of hosting services available. GitHub is among the most widely used. I'll log into an account that was set up earlier and create a new repository named Project 1. The remote repository is now available, so I'll copy the URL. Back in the local repository, I'll use the git remote command to associate the remote repository's URL with a name, which I'll call origin. The push command is used to upload the master branch from the local to the remote repository. Returning to GitHub, you can see that it contains the commits in the master branch. Another collaborator on the project could now copy the remote repository with the git clone command, specifying the URL. They can then modify files in their working directory stage the modified files, and commit these changes to their local repository. Once they're confident that the code is stable, they can push their local master branch to the remote repository. Origin is the default name Git gives to the server that was cloned from. Returning to the first user, he can now use the git fetch command to import the new commits from the remote to his local repository. The resulting commits are stored as remote branches instead of the normal local branches that we've been working with. This enables changes to be reviewed before integrating them into your copy of the project. To look at the changes, check out Origin Master. This is the master branch in the remote named Origin. If the user approves the changes a remote branch contains, he can merge them into a local branch with a normal git merge. First, check out the branch that's being merged into, and then run the git merge command. This will merge the origin master branch into the current branch. The repository contains a MVC web project. We could create a Microsoft Azure website configured so that when updates are made to the remote repository, the website is automatically updated, known as continuous deployment. Opening the Azure portal, I'll create a new website, selecting Publish from Source Control. In the next dialog, I'll select GitHub, followed by the repository name and branch. Clicking the URL, you can see that the website has been deployed. Commits that are pushed to the remote Git repository will now be automatically deployed to Azure. Thanks for watching this tutorial. We offer public courses in London, as well as on-site and private tuition. Please telephone or email for more information.